What's stopping you from being able to put the proper implementations in place to scale properly from a pod perspective? Probably it's something along the lines of you don't have the time to. It may not be important to management. It may not be something that moves the needle in terms of getting a big deployment out or getting production ready, so to speak, or something like that. Well, it kind of makes sense because scaling, whether we're going horizontally or we're going vertically, is important. You need it, especially for any production environment. You need scaling in place. Otherwise, poor performance right off the bat. You're definitely going to see it. But what is important also must be repeatable. That's why automation exists in the first place. So with that being said, we want a way to be able to manage scaling, but not actually touch it. So let's think about, well, first actually, let's dive into two different pieces of scaling: horizontal pod autoscaling, or HPA for short, and vertical pod autoscaling, or VPA for short. So let's talk about the differences here. You may have 1, 2, 3 pods, okay? And maybe these 3 pods, they're running as replica sets, they're in a Kubernetes deployment. And let's say they hit 75% capacity. Well, you got a few things that could go wrong, but primarily you're going to be faced with performance issues, and pods may go down because the containers inside of them cannot handle the workloads, okay? So because of that, maybe at 75% capacity, maybe at 80% capacity, you say, okay, I need to add another pod. But of course, you don't want to do it because that would be manual and that would be quite boring and probably very annoying. So instead, you're going to have horizontal pod autoscaling set up to say, okay, 3 pods at 80% capacity, add a 4th for me. Oh, add a 5th, add a 6th, okay? And then around and around we go. So horizontal pod autoscaling scales horizontally, like in the name. Vertical pod autoscaling is a little bit different, okay? So maybe you have 1 pod, 2 pods, and those pods have X amount of memory and X amount of CPU. Once they hit 75% to 80% capacity, instead of creating more horizontally, what'll happen is the memory in the CPU will just scale up. So automatically more CPU and more memory will be added to the pods, okay? So those are the big differences between horizontal pod autoscaling and vertical pod autoscaling. So what I want to do really quick is I just want to show a brief set of code to kind of think about, what we would be doing from a scaling perspective. All right, so first we have the horizontal pod autoscaler. That's the object or the resource in our Kubernetes manifest. And essentially what we care about is this piece right here, the scale target ref. So what you're going to do is you're going to specify the API version where your resource or object is, what kind it is rather, and then the name of it. And then you're going to specify min count, max count. So essentially what this means is this: I want a minimum of 4 pods running, and they are allowed to scale up to 10 pods based on load, and then they'll scale down, of course, automatically when those resources are no longer needed. And then it'll scale based on CPU, and it'll scale if the CPU hits 75% capacity. All right. Now, on the flip side, vertical pod autoscaling is going to be a little bit different. Vertical pod autoscaler is the object or the resource that you'll use. You'll specify the target reference, and then the update policy, you can set it to auto. So it's going to automatically increase CPU memory. But here's the problem. Number one, resource quotas, limits, requests come into play here in terms of how many resources you actually need to give each deployment. And are you going to sit there and manually figure out what resources you need to give? Okay. Now, on the other side of this, you need to set up, whether you go with horizontal pod autoscaling or vertical pod autoscaling, you need to set this up manually for each deployment, for each implementation. So yes, this is important and you need this in production, but doing it yourself from an engineering perspective is mundane. You shouldn't have to do this. So how can we get around it? Well, we can get around it with StormForge. specifically StormForge Optimize Live. All right, so I have StormForge open here, and to be honest, it's pretty straightforward. So I've connected my cluster already. I go to workloads, and then from here, right off the bat, I see current requests and I see with optimization. So we can see a lot of differences here. So I have a demo app deployed right now, and essentially, what we can see is I can go from $3 to 31 cents. I can go from almost $3 to 5 cents. Okay, I can go from almost $3 to 4 cents. And this may seem small, but add that up. And this is just one demo app, okay? Add it up for all of your production level workloads. Yeah, it's going to be a lot. So what I can do is this. I can go to front end, okay? And again, I can see current and I can see with optimization. And what I want to do is I'm just going to generate this. So it's going to generate a recommendation. I'm going to see if anything is updated here. I just did it, so I don't think that there's going to be anything. No, nothing here. And then what I can do is I can specify two different options. Number one, I can download this patch here. So let me go ahead and do that. All right. And then when I open it up, as you can see, I have a couple of annotations here specifying the StormForge configuration. And then it's going to tell me what my resources should be from a limit and from a request perspective. But still, I have to implement this. Okay. I don't want to do that. I want a tool or a platform to just handle this for me. I don't want to care about HPA. I don't want to care about VPA. I know it's needed and I know it's important and I know it needs to be implemented, but I also don't want that to be yet another thing that I have to manage and worry about and put out the fires around it, right? I want a repeatable process. Again, like we talked about in the beginning of the video, that's why automation exists in the first place. So what I want to do is I want to click, well, first, actually, we can just take a quick look. All right. We'll see the impact here of this specific pod. We'll see some recommendation details here. And then we can see the config, right? So the config, we can specify if we want to manually set up the config. We can set up some automatic deployments. We can set up CPU and memory optimization based on savings, balance, and reliability for this particular container right here, right? Or we can just take the recommendation from StormForge, click apply now, apply recommendation, and that's it. That's all we have to do. We don't have to do anything else. It's applying and boom, that's it. And we can come in here and always check. We can always generate a new recommendation and see what StormForge recommends based on cost and resource optimization. So instead of setting up horizontal pod auto scaling and vertical pod auto scaling yourself, just let a tool do it for you.